In this video we're going to look at two-dimensional lists in Python. We've already seen that a list can have elements that are themselves lists or sublists. But now what we're going to be doing is looking at a case where we have essentially a rectangular table or grid of values. And the way we're going to do that is by having a list in which every element is a sublist, and each of those sublists has the same length. And I've written it in such a way that it makes it obvious here, right? You can see here we have 5 sublists, and each of those 5 sublists has a length of 8. So each sublist represents one row of the table of values. For example, the sublist that I've highlighted here would be the top or first row of the table. And the overall structure is referred to as a two-dimensional or 2D list. Okay, now let's go ahead and enter our 2D list into the Python shell so that we can talk about how to figure out the dimensions of a 2D list. I know the dimensions of this particular 2D list are 5 rows by 8 columns. But what if I have to write code that works with an arbitrary 2D list? Well, if you think about it, the number of rows is just the number of sublists, and so that's just the length of your overall list. So len table tells me that I have 5 rows, and in general I can figure out the number of rows by just using length on the overall list. Now, the individual rows can be obtained using indexing. So for example, table 0 gives me the first row, table 1 gives me the second row, and if you think about it, if I do len table r, I'm going to get the number of elements in row r, and if we assume that the number of elements in each row are the same, I can get the number of columns just by using len table 0, because I know I'll always have at least one row. And you can see we get 8 here. In theory, you could use a different index here, because they should all have the same number of rows. So for example, len table 1 would also give me 8. But typically we use len table 0 if we want to know the number of columns. One way to picture a 2D list is as a spreadsheet or a grid, as you see down here, and I've labeled the indices. So the column indices go from 0 to the number of columns minus 1, and the row indices go from 0 to the number of rows minus 1. If we want to actually access a given element in a 2D list, we need to supply 2 index values. The first index is for the row, the second for the column. So for example, if I say print table bracket 2 bracket 1, that first index is the row index, so it tells me I'm focusing on the row whose index is 2, which is actually the middle row here, the third one down, because it's 0, 1, 2. And then the second index is the column index, and it's telling me that I want the second value in row 2, which is the 3. And so I'll end up printing 3. You can also change what's in a given position by using an assignment statement. So here I want the last row, because I'm using an index of -1, and the second to last value in that row, because I'm using a column index of -2, and right now that value is 3, but I'm assigning a 0 to it, and so the 3 will get replaced by a 0. Now typically if we want to process an entire 2D list, we're going to use a nested loop. The outer loop will process one row at a time, and notice I'm using for r in range len table. Len table tells me how many rows, and so r is going to take on the appropriate index values for each row. And then for each row, we're going to use a nested loop to iterate over the values in that row. And I'm using C here for the column index. And notice it's range len table 0, because len table 0 tells me how many columns. And then for each iteration of that inner loop, I'm going to process the appropriate element in that row, the element at row R, column C. Let's trace through a concrete example. So let's assume we have this table, which is a little bit smaller than the earlier one. we want to count how many values in it are greater than 15. So we initialize our counter to 0. We then begin the outer loop, and because len table in this case is 3, range 3 is going to give us the values 0, 1, 2, and r is going to take on the first of those values. So we're going to start by focusing on row 0, which is the top row. Then we begin the nested loop. Range len table 0. So again, len table 0 tells me how many columns. In this case it's 4. And so range 4 gives me these 4 integers, 0 to 3. And C starts by taking on the first of those values. So we're focusing first on column 0. And the value at table RC is the value at table 0, 0, which is the first value in the first row, or 15. And we test to see if it's greater than 15. It's not, so the counter does not change. And we go and we get the next value of C, which is 1. So that moves us to the 19, because now we're in column 1. It is greater than 15, so we increase the counter by 1. We go back and get the next column value, the next column index, which is 2. That gives us the 3, because row 0, column 2 is the 3. It's not greater than 15, counter doesn't change. We get the next value for C, which is 3. That gives us the 16. It is greater than 15, so we increase the counter. At this point, the inner loop has processed all of the values from range 4, so we're done with this particular execution of the inner loop. We go back and get the next value for the outer loop variable, which is 1. So now we're focusing on row 1, the middle row. We start the inner loop over again. Row 1, column 0 is the 6. It's not greater than 15. Counter doesn't change. We get the next value for C. Row 1, column 1 is the 21. It is greater than 0. We increment the counter. And we continue this same process. The counter gets updated again for row 2, column 0, which is the 17, and finally for row 2, column 3, which is the 18. That completes the processing of the 2D list, and we go and we execute the print statement, which prints the final value of the count, which is 5, which is the number of values in the 2D list that are greater than 15.